You're all very welcome back to another episode of Line Boring. I'd just like to take a moment to thank all of our new subscribers. You got us over the 100 subscribers mark. Thank you so much. If you're new to watching the video, don't forget to subscribe. Let's head over to the bench now and see what's next in this episode. Okay, we're back over at the engine block now, and the next step in this process is going to be getting this cap bolted down properly. We are changing from a 2-bolt to a 4-bolt cap, so we have the original 2 fasteners and we're going to add 2 fasteners. The best way to mark this out is using what's called a transfer punch. I've turned one up here from an old cap bolt just by putting simply a point. One of the things that's very important about making one of these transfer punches is it must be done on a lathe, as that must be in the absolute center of the punch. Transfer punching is really easy. It just needs to be a good fit in the original hole. Put it in place, give it a crack at a hammer. Put it in place on the other side, give it a crack at a hammer. And what we have now is 2 punch marks in the engine block at the dead center of the holes. Let's head over to the milling machine, get these holes drilled and tapped. Okay, we're over at the mill now and we can do the next step, which is going to be drilling out these holes and tapping them. So we're going to center drill them first at each one of the holes, then we'll drill them out with a pilot drill, drill them out to tap size, and then we will tap it. Okay, we've all our drilling, tapping and threading done now. I've substituted in 2 bits of M10 threaded rod here with just some normal 8.8 fasteners. We have some nice 12.9 cap heads ordered, but they're taking their time in the post, so we're going to use these for now. I've achieved the proper torque of 80 foot-pounds on all 4 fasteners, so I'm more than happy that it won't affect distortion on the cap or anything like that. Let's head up to the Colchester now and get set up on the bed of the lathe for our boring operation. Okay, we're set up here on the lathe to start our line boring procedure. I just want to run you through the setup here first so that you can get an idea of all of the parts of the video hopefully now starting to come together and see what it is we're doing. So what I have is I have the engine block clamped down here to the bed of my lathe. I have removed the cross slide and compound, so I'm just straight down here on the base plate of the lathe. What we have on this end is the truss bearing block. You might have heard me talk a little bit about this before. So I've made up a piece here to connect the bearing block to the bed of the lathe, and I have the bearing block sitting here. I just want to show you, I have the grub screw just released on the bearing block, and I just want to show you how free that is there. So that is not affecting thrust or alignment in any way on the boring bar. It's just simply there to hold the boring bar to stop it from moving left to right and up and down. Okay, we have our bushings in here, which are centralizing the boring bar for the cut we want to do at the bar. What I'm going to do next is I'm going to bring the cutter in and I'm going to set clearance. So what I have here is my 3000 feeler blade or 0.7. I'll bring the cutter in and I'll set clearance off the top of the bearing cap. Then we'll take 1 pass across the cap to make sure that we have no clearance issues anywhere on the cap and there's no high spots. And then we can start adding measurements using our dial indicator gauge to get an idea as to depth of cut we can run. I've got your camera angle moved in and hopefully you can see now we've done our spring pass and we've just started to clip the cap here. The other back side of the cap isn't getting cut yet, but that's completely normal. It's why we're doing line boring. I'm going to dial in another 5,000 depth of cut here. I constantly like to creep up on these measurements. I never like to take a big cut at one time. I like to just creep up. It's easier on the line boring bar and it's also easier to take more metal off than it is to replace it. So like the last time, we just back off these, slacken off one and nip, slacken off the other and nip, and then we'll be able to just tap in what we want, the amount of clearance we want. So this indicator gauge is in millimeters, so that's 0.1. 5 thousandths is 0.12, but let's just go for a measurement we know. Right, let's take another pass. have line bored the cap now to where I think we're very, very close to the right measurement. So I have the dial bore gauge set up here with the correct clearance for the cap, as can be seen off this cap. So if I move the gauge in any direction, the dial bore indicator starts to read lower figures, indicating the bore is getting bigger. So that's the front one. So let's try the one that we've just bored and see what measurement we get on that. So let's get the gauge. So we have minus there and we have 0 there. So that tells us that this bore is exactly the same as that bore. The last machining operation to do on this engine block is to bring the thrust faces in. The thrust faces are what gives the crank lateral thrust control. I've a cutter which I made off camera here, which is just a simple piece of high-speed steel welded onto another one of these bits of boring bar, and we can just slowly move the cutter up and bring the face in. We're matching our thrust face here. So we want to bring this in until we see the two thrust faces coming together, and that's our machining operation done. And that's it, all done. We have our line boring done on our main cap, and we've machined in our truss faces. Thank you very much for joining me on this series where we got tooled up in our own home shop to be able to line bore and bring in truss faces on A-series engine blocks. If you liked what you've seen, please don't forget to give us a like, share and subscribe. Thanks a million to all the new subscribers, and we'll see you next week when we start the latest project.